Yes.
Okay. Okay. So only 7 people joined in this session, right? So this session is for science background students, if I am not wrong. Yes, no. Are there any non-science background students also? Okay. Okay, so we have come to week 4, right? So how do you feel about week 4?
Sir, easy only. Class 10th and class 11th level.
Okay.
Level.
Okay, nice. Uh, so week 4 is basically about the polynomials. So degree greater than or equals to 3 we are going to see in this week, week 4. Then what shall we do now? Shall we do some problems from activity practice, or shall we discuss a small concept and go to activity?
Sir, problems from activity.
Okay. Okay. So only Gurvinder is speaking. Uh, can I hear from others? सब अभी अभी उठा है क्या? Or else they simply joined and they are sleeping. Okay. Okay. Apurva is asking for brief summary.
Can you
So
explain SSC?
SSC.
So should we do some revision problems from the previous question paper?
Previous question paper means mock or week 3 graded?
Busy papers, qualifier paper.
Qualifier paper.
We don't have, so can I get access?
You will get a mock paper, right? Mock.
Previous question papers, if we do something, we may get some confidence that we can get through. If we know some questions like it.
Hmm.
If we do some problems, 3 weeks problems.
Acha, okay, I understood. But week 4 is also important equally, right?
Polynomials is a bit, if we understand the graph and everything, it's easy only, sir, compared to week 2.
Compared to straight lines,
Not straight line, there are problems, the practice problems and everything. A graded assignment that was easy.
okay. Okay, how many of you agree with Sarvani? Like, shall we do problems from week 1 to 3, or shall we do problems from week 4?
Easy papers.
Yeah, quiz. See, there is nothing like quiz. You can raise your hands. Uh, Nothing like quiz is a different level. Whatever the graded assignments and practice assignments you are seeing, even the quiz questions are also of the same level.
Mm.
Okay. So if you are able to solve without seeing the solutions,
Mm.
then you will be able to solve quiz paper also. So how was mock for week 1 and 2?
Mm. Okay, sir.
Hmm?
Mm.
Is it okay? Is
Yeah,
it okay or is it not doable? Is it
it's
difficult?
doable, sir. Mm.
Doable?
Yes.
Similarly, mock for weeks 1, 2, 3, 4 will also be in that level.
Mm.
And also the quiz level is also of same like mock exams.
But that functions identifying reflexive transitive, somehow I get confused.
Okay.
That those confusion is not there in week 4.
Okay. So, okay, some inputs from you I will take now. Now I will design my session like I will start with few important concepts from week 4, like how to graph a polynomial. Okay, what are these turning points? So, do everyone know what are these turning points, multiplicities of zeros?
Yesterday, Shar has revised those.
Yesterday also, sir has taught about it. Like we can find the minimum degree of a graph of a function
Mm-hmm.
by using that.
Yesterday,
Yesterday. Okay,
week 4 revision was.
done. Is it? Okay, okay. Then we will skip revision part then. Then I will do something. Week 4 we will deal some moderate to difficult problems, which are from maybe activity and also from practice assignment. After that, we will just slowly go back to week 3, week 2, and week 1. So we will deal with problems completely. Okay. Is
Week
that okay?
1 could you take first, sir, instead of week 3?
Week 1, is it?
In that order, I want you to.
Okay. So week
Because
4,
this,
okay.
some doubts are in the previous week, means next week also it is reflecting. That is why I am asking.
Okay, we will see.
Yes, sir.
Okay. Let us start with week 4. We
Okay,
will
sir.
try to complete week 4.
Yes, sir.
Once if week 4 is done, then we will decide what week to do.
Okay, sir.
Okay. Okay, let me share my screen before that. Just a second. Okay. Is my screen visible?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Yes,
right?
now visible.
Okay. So I will try to take what I felt as moderate to difficult. You can also suggest me like question 1 or 2 or like this. So question 1 is basic polynomial thing, correct? So I don't think that is difficult. And also question 2. So for question 2, you need to know what is monomials, binomial, and trinomial. So can someone tell me what is a monomial?
Sir, which is having only
Only
one
one
term
term.
and
One term. So one term can be any term, whether it can be constant term or it can be a linear term which is having x, or it can be quadratic term which is having x square, like that. So from this, how many monomials are there in this given? So the terms are expressions are x plus square root half. Is this a monomial? This
it is a
express,
binomial.
yeah.
No, sir, binomial.
See, you can see that there are two terms. One is a constant term, which is square root half, and there is a linear term, which is x. So there are two terms, which is not a monomial. So we will check for monomials. So this square root x power 4 by 2. So which is x square by square root 2. So which has only one term, quadratic term. So this is a monomial. And the next term is 0.001. This is also a monomial. That's it. So there will be only two monomials. Similarly, binomial means it should contain two terms. Whether it can be combination of linear term and constant term, or cubic term and constant term, or cubic term and quadratic term, like this. But it should only contain two terms inside it. For example, like this, x plus square root half. So it has two terms. Similarly, square root x by 2. So you see this square root x by 2, is this a polynomial? Second term, square root x by 2 minus 2x square times x power 8. Okay, why this is not a polynomial?
Sir, it is also binomial because under root x by 2 minus 2 and this powers we can add like 2x square into x to the power 8 it is given. It can be written as 2x to the power 10.
Okay. So tell me whether this is a polynomial.
No.
No is correct.
Division is allowed as a for variable square root of x by 2.
Square root of x by 2 is nothing but 1 by root 2 into root x, right?
So the term is
Hmm.
allowed.
See, all the terms in our polynomial should be consisting of either constant or linear or quadratic or cubic, like this. So it should be like x to the power 0 term, x to the power 1 term, or it should contain x square term, x cube, x power 4. So the power will always be a natural number.
Okay, sir.
So x to the
Coefficient
power
can
will,
be a fraction.
it cannot
Coefficient,
be,
yeah.
coefficient can be fraction, or coefficient can be any real number.
Okay, sir.
Okay.
But x is in root means whether it is okay. I was having doubt. That is why I am asking.
Okay, just a second. Let me share my complete screen, entire screen. Yeah. I hope my entire screen is visible. See, the way polynomials are defined is so f r to r, where f of x is something like a n times x to the power n plus a n minus 1, x minus 1, and so on, a1 x plus a 0. You see, whatever the coefficients you are seeing, a n minus 1. So these terms can be real. So it can take any real value.
Okay, sir.
But this particular n you are seeing, right? So this n belongs to only natural number. And that too n greater than or equals to 2. So usually we call these kind of functions as polynomials. Okay. When n is equals to 1, it will be a straight line. When n is 0, it is a constant function. Okay. Generally we won't consider straight lines and a constant function into polynomials, but if we have to, they are also polynomials, but usually we won't consider them. We will start considering from quadratic functions. So this is how
n
it should
is
be.
n
So
is greater than or equal to 2 means always it will be even number, sir.
no, it's not always equal to
It
even
can be an
number.
odd also.
It starts from 2 3. So simply if I have to write it explicitly, n greater
My
than or
doubt
equals
is
to 2.
odd number square root means it may give fraction number, no, sir. That is why I got doubt.
That is why it will not be a polynomials.
Yeah.
So n can only take values from 2, 3, 4, 5. So it cannot take, n cannot take something like 2.5 or 0.5,
Okay,
something
sir.
like this, 2.3. No
Okay, sir.
rationals are allowed, or not even reals are allowed. Only natural numbers are allowed for n. So this condition is important. So that is why this particular
Okay.
root x by 2
Yeah.
I can write it as 1 by root 2 into x power half. So you see power, in power you are having 0.5. From this you can say this is not a polynomial first of all.
Yeah, that's only I want.
If this is not a polynomial, then this will not be any of it. So it will not be monomial or trinomial or binomial. See, these monomials, trinomials, binomials, all are. So we will classify them as monomial, trinomial, binomial only if they are polynomials firstly.
Okay.
Okay, so that is the thing.
And the
And
same
also
x power 1, x power 3 also, if we check what will be the case, sir?
x power.
Supposing square root of x power 3 by 2.
There also you see
Only
square
even
root of.
numbers will come out, no, sir, like a natural number.
See, x power 3 whole to the power half. It will be like so. Square root of x cube is nothing but x power 3 by 2. So 3 by
Okay,
2 is
sir.
1.5 again. So x power 1.5.
That is also will be in fraction, no, sir.
That will also be in fraction. So it will not be a
So
polynomial.
that n can take only greater than or equal to 2, 4, 6, like that, whatever even numbers that can be square root will be in natural numbers. Like that I got.
If there is a square root, then the
Yeah,
power should always be even.
yeah, that is the case, no, sir.
Correct.
Okay, sir. Okay.
So
And in the same
similarly,
way that division also, please tell me, sir. The 3 terms by x square is there, no, sir? That also,
this one, right?
yes, sir. Some light you pour, sir.
Uh, so if you see that particular polynomial itself,
Yes, sir.
so x cube minus what
Plus
is that?
5x square minus 8x.
Plus 5x square minus 8x, right? Divided by x square, right?
Yes,
You
sir.
can split the terms. So you
Okay, sir.
simply split the terms. X cube by x square is one term, plus 5x square by x square is another term,
Okay, sir.
minus 8x by x square. So from here, this 2 and this 3 will get cancelled. This will get cancelled. X will be remained, right?
X plus 5 minus 8 by x.
So you will be remained with x plus 5 minus 8 by x. You see this. So x is okay. Plus 5 minus this 8 into x power minus 1. So look at
Yeah.
this power minus
Again,
1.
yeah.
Uh,
Again, it will not be
It will also not be a
uh,
polynomial.
that definition. No, sir. Definition will not be satisfied.
Definition will not be satisfied, as well as power. When you see x to the power something, that something should always be a natural number. So it will start from natural number, starts from 0, right? So either
Okay.
it should be power 0 or power 1 or power 2. But this is like negative number, x to the power
Yeah.
minus 1.
So whenever in that denominator, no, sir, divided by, that is coming, if we write in the straight line, it will be in minus only, no, sir, always.
Not always. So you see the powers here,
Divided by
okay?
x2, no, sir, by x2 means x
Hmm.
or x cube, whatever may be in the denominator. If we write minus x into that x power means it will be minus only, no, sir.
Not always. See, I will give you an example. So you see the power, least power in the numerator and the least power in the denominator.
Oh, it will
Okay.
be get cancelled means no problem.
If it is
Whenever it
get,
is remaining, whenever x is remaining in the denominator means it is not a
it
polynomial.
is not a polynomial. Correct.
Okay, okay.
So if denominator power is greater than one of the terms in the numerator power, then it is not a
Then
polynomial.
it is not a polynomial.
Yeah.
Okay, sir.
Okay.
This is only I got doubt. Okay.
Hmm. So let's move. Let's move for 4.2. So this is also just the terminology of polynomials. Okay, you can see here, right, the degree of a polynomial of square root x to the power 8. So the square root x to the power 8 is nothing but x to the power 4. So from there you can tell me the degree of a polynomial, right? So I hope everyone know what is the degree of a polynomial.
Yes, sir.
Yes, right? So I don't think these are very difficult things. Okay. So anyone having any problem in AQ 4.2 questions? So it's just the lecture on degree. I don't think anything will be there. If there is, you can ask. Nothing, is it?
Sir, no, sir. This in this 4.1, no, sir.
Hmm.
Multiple select question.
Hmm.
Mm. Third option, 10x power 16. That is there, no, sir.
4.1
4.1,
or 4.2?
4.1, sir. Oh, no, 4.2. Sorry.
4.2?
Fourth question, sir. Fourth
Hmm.
question.
Acha, 10 this thing, is
Yeah,
it?
yeah.
Okay, okay.
How it
So,
is 18? That
okay.
is correct answer also.
Okay. Hmm, Just so it is given that square root of
X power 16.
10 times x to the power 16 into y to the power 12 and z to the power 8. So we need to find degree of the given
Yes, how it is 18, I don't know.
polynomial. Okay. So firstly, what is the degree of a polynomial? It is
Largest power,
highest
no.
power.
Highest power. Highest power.
Hmm. Highest power in the
That expression.
given expression. So in this case, see whenever there is only one term,
Okay, sir.
we will just see the power of that particular term, right?
Okay, sir.
Whenever if it is a product of two different terms, something like x to the power a times y to the power b times z to the power c.
Okay, sir.
So if there is a term like this, then the degree of this term will be, so degree of x to the power a, y to the power b, z to the power c will be a plus b plus c.
Oh, oh.
Okay. So you should add the powers of each and every variable. So x to the power a, you have a x's.
Only 36, sir.
Hmm.
36 means 6 only will be the root, no, sir.
There will
But
be
half
square.
every. How it is by 2 they give, sir.
So it's not square root of 36. So you
Okay,
see
okay,
here.
sir.
So this, okay. You have this, right? So 10 x to the power 16, y to the power 12, and z to the power 8. So what is square root? It's just the power half, right?
Okay, sir. I am not sure, but that is why I am asking.
Uh,
I don't have that such a
okay.
background. That is why.
Under
So,
root 10
Okay.
will be there, x to the power 8, y to the power 6, and z to the power 4.
correct. So square root
Oh,
is nothing but to the power half.
okay, sir. Thank you. Thank you.
Okay, yeah. So simply you can write it like this. So x to the power 16 times half. So which is 16 times half. Something like this. It will be like this. So 12 times half and 8 times half. So from this you will get x to the power 8, y to the power 6 and z to the power 4. And there will be square root 10. So you
This
don't
is
need to
only
worry
one,
about.
sir, this is only one term, no, sir. Supposing without square root also, 2-3 variables are there. We can compare the power alone and degree will be the highest power.
Highest
Is
one.
that, sir?
Correct. So x
At home
square.
with single variable only, multiple variables also we can treat to find out the degree of the term, no, sir.
So in this particular expression, so the degree of this particular polynomial will be 7.
Sure,
So
sir.
degree of this term is 2 plus 3, 5.
5.
And degree of this term is 6 plus 1, 7. So the total degree will be 7.
12 by 6. 12 by 2, 6.
What is it? 12 by 2, 6?
6, 6. Oh, this term 6 plus 1, 7. Okay, sir.
7.
Okay.
Okay. So like this. Okay. Well, let's move then. Let's solve difficult problems. So even 4.3 also. Okay, choose the correct option. Okay, 4.3 is also okay. From your side, any doubts from 4.3? So silence, I will take it as no. Okay, yeah. Okay, 4.4. How do you solve the first problem?
The third one, sir.
Is the product of a degree
Find the slope
two
of this given
polynomials.
equation.
Directly, sir, we have to multiply. Like here, it is given that it is the product of two. One, it will be px and its slope. So like here it is given 8x cube plus 12x and plus 2. So we have to differentiate it and then we'll multiply both and we'll check that what is the highest power and what is its coefficient, and that will be the answer.
Correct. So what will be the slope equation? Slope function. So what will be r of x?
Slope,
16x minus
equation
12.
16x minus 12.
16x minus 12 or minus 16x minus 12?
Minus 16x minus.
Sir, on mobile it's visible. Only 8x square and
Okay,
12x and 2 are visible.
Oh. Okay, let me zoom this one.
Now it is visible. Minus 8x square minus 12x plus 2. So it will become minus 16x minus 12.
16x minus 12. Okay. So that is r of x. And we have given you p of x. We asked you when I do the product between p of x and r of x, what will be the coefficient of the term with highest power? So compute it and you will get the highest power as x cube, cubic term. And for that, you might get the positive value, right?
So that will be
16x.
minus 8 into minus 16, and that will be 128.
128.
Option
Yeah.
C.
Yeah, option C. So that is how you have to try.
Steps, no, sir. This sum alone, you write the steps, no, sir. It will be easier for me to understand.
First question. No?
Yeah.
Okay. So we asked you the product of. So first and foremost thing is you have to do product of r of x and p of x. I know only p of x, which is minus 8x square minus 12x plus 2 plus 2. Is that correct? Yeah. And I also know that r of x is
Product of slope and this expression. This one.
No, r of x is the slope function.
So
And I
equals to
know,
p dash x.
okay, p dash x, if the people know differentiation, it's okay. But from week 3, if you remember, if there is a quadratic function, slope at point x will be 2ax plus b. So that also you can do.
Okay, sir.
So
That
r of
formula
x,
we have to take. Okay.
r of x, you see a is -8, this is a, this is b, and this is c. So a will be -8, b will be -12, c is 2. So r of x will be 2ax plus b, which is 2 times -8 x plus -12. So b is -12. From here you will get -16x minus 12x. So now I know r of x and p of x. I want the product. So let me say product as something like k of x. So which will be r of x times p of x. So minus 16x minus 12 times minus 8x square minus 12x plus 2. So from here, if you do the product of these two polynomials, you can, so no need to compute the total product. Just see where will the highest term occur. So if I product this term, highest term of this polynomial and highest term of this
X cube.
polynomial, yeah,
It
you
will
will
be
get the
highest.
highest term. So
Okay.
you have to product,
X
you have to see the coefficient of this. So minus
16
16x
into
times
8.
minus 8x square.
Oh,
So from this you will get
128.
128. Yeah.
128x power
X
3. No,
cube.
sorry, x cube. Yeah.
So x
Okay.
cube, you can see that x cube will be the highest term, and we ask you the value of this coefficient of that.
Okay. Thank
So
you.
128 will be the answer. Okay.
Okay.
So that is like that. And
Yeah.
the next is the just the product. We asked you the product of two polynomials. You just compute the product. And again, this is when you do the product, what will be the equation look like? So when you do
Sir,
the above product,
third, yes, a third problem also you just explain me, sir. This um, that symbol, no, sir. What does it called? It is
this
called
one is called
exponential
summation. Summation.
summation.
Yeah.
Okay, okay. That writing, how to write it, I am not sure.
Hmm.
Kindly explain once.
Hmm.
In this problem also, you can tell me. Sir.
Okay. Okay. So we have given two polynomials, right? So
Yes,
one
sir.
polynomial we said p of x as something like summation k equals to, so we have used a and b, right? Okay. So k equals to 0 to n ak times x power k, and p of x and q of x as something like summation k or j, what we have used. Okay, j.
J.
Okay, it doesn't matter. J is just the variable.
Okay, sir.
M, bj, and x to the power is there. So what this means is I have to take, I have to start taking values for k starting from 0 till n, and once if I take all the values, I have to add all those values. So something like this. So if k is 0, then this particular term will be a0 k to the power 0, correct? So when k is 0, just substitute 0 in place of this k
Sir, x
Okay,
to
in
the
this
power
term.
0, no, sir.
Oh, sorry,
sir.
sorry.
X power 0, no, sir. X power.
X to the power
X to the
0.
power 0. Yeah.
Okay, sir. It will go
And
up to n. That is
it
like,
will go up to n. So after 0, the next term will be 1. So k is 1. So when
okay,
k is 1, a1 x to the power 1.
okay,
K is 2, a2 x to the power 2. And like this, I will reach till an x to the power n. So you have to go till n. So k
okay,
is equal to, And what you have to do, this particular summation means you have to add all those terms.
With these two. Only variable will be a change, no, sir? What choose current product we have to write, sir. Okay.
So summation, this is sum. So this is one term. So this
Okay.
refers to k is equals to 0. So this is k is 1. When this is k is 2. And this is k is n. Okay.
Okay, sir.
So you have to add all these n plus 1 terms. You will have n plus 1 terms. So
Okay,
this
sir.
particular summation k is equals to 0 to n represents this.
Okay, sir.
Okay. And this will be equals to this. So now this is a polynomial. You can see a0 plus a1x plus a2x square and so on an x to the power n. So this is a polynomial with degree n.
Okay, sir.
Okay. Similarly, q of x is also another polynomial.
Instead of
This will
K, it
this,
will be J. Okay.
so here it is. So when j is 0, you will get b0 x to the power 0. When j is 1, b1 x to the power 1, like this, b2 x square.
Up to M, it should be.
So bm x to the power m. So this is also another polynomial
Okay, sir.
with degree m. So now we asked you the product and sum. Did we ask sum? No. We only ask for product.
Product.
So what happens when p of x times q of x? Okay. So I'll write it like. So I have a naught x naught plus. So x to the power 0 I will just simply replace with 1. So a0 a1x plus a2x square an x power n times b naught plus b1x plus b2x square. Okay. Now see, how do we compute the product? You take one term from this and you multiply it with every other term in the next expression.
Yes, sir.
Correct? So
Sir.
a naught will be multiplied with b naught.
Peanut.
Similarly, this a naught will be multiplied with b1x.
1x. Yeah.
And a naught will be multiplied with b2x square and so on, plus a naught will be multiplied with bmx to the power n. Correct?
Yes, sir.
Next we will move to a1x term. So I will write it here. So a1x will be multiplied with b naught plus a1x will be multiplied with b1x plus and so on
Up to M.
a1x
N and M. Okay.
a1x will be multiplied with bm minus 1 x to the power m minus 1 plus finally a1x will be multiplied with the last term bm x to the power. Okay. Now similarly move to the next term. Just a second. Okay, I'll just move this to here. So you'll get to know why I'm writing like this. Okay. So a1x will be multiplied with bm x to the power m. So you know the before term, right? So I multiplied with the before term. Just before bm
Okay.
x to the power m, it is bm minus 1 x to the power m minus 1.
Okay, sir.
Okay. So I have multiplied that. Next term is, so a1x is also done. Now a2x square should be multiplied with each and every term. Now
Okay.
here. So a2x square will be multiplied with b naught So a2x square will be multiplied with b1x and so on here,
Okay, sir.
plus a2x square will be multiplied with bm minus 2 x power m minus 2 plus a2x square will be multiplied with bm minus 1 x power m minus 1, and we will have a2x square. So a2x square bm x to the power m. Okay, and this will go on.
Okay, sir.
This will go on till the last term is multiplied.
Okay, sir.
So you have to multiply an x to the power n with every other term.
How this will be
We
represented with summation symbol? That
we will
yeah.
see. Plus bm x to the power n. So this a n x power n will be multiplied with all this. Now you see here. So this is the constant term you have. So the only constant term you will get from this product is a naught times b naught. That's it. You won't get any other constant terms.
Okay.
Is that correct?
Yes, sir. Then only x power will be 0.
Ah,
So all other products, if it is multiplied, there will be x. So x
correct.
power 0 only, it will be a constant. Okay, sir.
So this
Understood.
is a constant. So this is constant term. Now you see these two terms, a naught b1x and a1x b naught. So only these two terms will be linear terms or x terms.
Other terms will have power more than
More
1.
than x, more than
Yeah.
1.
Yeah.
So you
Yes.
see this particular x term is multiplied with constant or constant is multiplied with x.
Yes,
So these
sir.
are the only two possible cases for getting linear term or x to the power 1 term. Okay.
Okay. Okay, sir. Understood.
Now see this. So a naught b2 x square or a1 b1 x square or b naught a2 x square. So these are the three terms
With the
that
x
will
square.
have
Yeah.
x square term.
Okay.
Okay. So observe the pattern. Okay. So for constant term, you have only a naught b naught. Okay, as the coefficient.
Sir. Yes, sir.
Okay, for x term, I will just say x term. Okay, for
Yes, sir.
simplification, or linear term also you can say. For x term, so x to the power 1. Okay, so this is x to the power 1, and we have coefficients as a naught b1 plus b naught a1. So you see this, so 0 1 or okay, a1 b naught, I will write 1 0. Okay, either it can be 0 1 or 1 0. If I see the x square term, okay, it will be a naught b2 plus a1 b1 plus a2 b naught. Okay.
Yes.
So from above only, we just, so whatever the coefficients are there for x square are a naught b2, a1 b1. So if I simplify this, it will be a1 b1 x square. So this is a2 b naught x square. So these are the only three terms you will have.
Okay, sir.
Okay, now observe, so constant term or x to the power 0 term. So for x to the power 0 term, you see this particular terms, this subscripts. So 0 and 0. So 0 plus 0, 0. You are going to get the power. So here also 0, 1 or 1, 0. So if I add, I will get 0 plus 1 is 1, 1 plus 0 is 1. So those will give you the x to the power 1 terms. These are combinations. If you know combinations, or else So don't worry about it.
Okay, sir.
X square term, you see x square term. So A is getting 0, B is getting 2. So 0 plus 2 is 2, or 1 1 or 2 0. It's like you are adding two things, uh, P plus Q, and you are getting 2. So how many ways are there?
Okay, sir.
So P can take 0 or 2 and Q can take 0. P can take 1, Q can take 1, or P can take 0, Q can take 2. So three possibilities will be there.
Okay, sir.
Okay, like this.
Thanks.
So these are the three coefficients. So like this, if I proceed and if I see the x to the power m term, so it will be like this. So either it is a naught
And plus
bm,
one terms will be there.
m plus 1 terms will be there, and the terms will contain the coefficients of those terms will be a naught bm, or a1 bm minus 1, a2 bm minus 2, and so on, am b naught. Okay, like this. So for x to
Okay.
the power 0 term, you will have one term. X to the power 1, we have 2. X to the power 2, we have 3, like this. X to the power m, we will have m plus 1 term.
Oh,
Okay.
okay, okay.
Now you can see the coefficient of x to the power m term in the given expression. So this is so you can replace m with any number. Right?
Okay,
You
sir.
got the general
Form basis.
coefficient, general term ka coefficient. So m you can replace it with anyone.
Okay, sir.
Okay. So now what is this? I want the complete product, is it?
Yes, sir.
Okay. So when I wanted the complete product, I have to see whole. See, this is A naught, B naught. So I wanted to write in two different summations. Okay. So one is for A and one is for B.
Okay, sir.
No. One is for
K and J, sir.
no. One is for A and another is for power. Okay. One is for this subscript and one is for power.
Okay, sir.
Okay. So you see, I will see the general term only. Let us pick the general term only. These are the coefficients of this is the coefficient of x to the power m, right? X to the
Yes, sir.
power m. Uh, Now if x is to the power m, then I will get the subscript till m. So starting from 0 to m.
Okay, sir.
Okay. And also the sum will be m always. So 2, so 1, 0 plus m, 1 plus m minus 1, 2 plus m minus 2, like this, m plus 0. So every term, if I add the subscript values, so subscript is below 1, below numbers. Okay, you know subscript, right?
Yes, sir.
Power means it will be on top. Subscript means it will be below.
Okay, sir.
Okay. So the below numbers, if I add, it will always be m.
Okay, sir.
Okay.
In each term.
In each term.
Okay.
And this is just the summation, right? I don't want to, I just wanted to remove this plus now.
Yes, sir.
Okay. If I wanted to remove plus, so you see here, initially, if I wanted to remove this plus, I have used this summation symbol, right?
Okay.
Summation symbol, and identified the generalness of each term. So how is the each term is? So you see each term has, if I say A is having some J, subscript j, then definitely B will have m minus j because the sum should be m,
Yes, sir.
correct?
Yes, sir.
And this j,
Yes, sir.
how can this j be? So j can take 0, j can take 1, j can take 2, and so on, j can take m,
Okay.
right? So that means I can write
Summation
summation j is equals to 0 to
equal to
m
0 m.
m. So this particular, if you again expand this, you are going to get this thing. So when j is 0,
Yes.
it will be like a0 bm, first term.
Okay, sir. Okay, sir.
Okay, when j is 1, it
Sure,
will
sir.
be a1 bm minus 1, the second term, and so
Okay.
on. When j is m, am b0, so the last term.
Okay, sir.
Okay.
Now I understood, sir. Thank you.
So this is inside summation. Inside summation of only one coefficient. Okay. So this is
Okay.
only the one coefficient. I have to add all the coefficients. This is the coefficient of x to the power m,
Yes, sir.
and this m can also vary. For that m, it can start from 0 till m plus n. The highest degree will be m plus n. So the last degree will be m plus n. You can see. So this term multiplied with this term, you will have x to the power m plus n.
Okay, sir.
Okay.
In product. Okay, okay.
In product, you will have m plus n.
Okay,
So
sir.
as already m used, so we can use k. So k till k x to the power k. Okay. So let me replace k here. So n m we already used. That is why I'm replacing k. So don't ask me why you are taking k again.
No, sir.
Okay. So just replace k. So now it is k x to the power k, and this k runs from 0 to m plus n. So now you can expand, right? So expand the inside term and expand the outside term. You will get the total complete this. Okay.
Okay, sir.
So there will be some. How many terms? Can anyone tell me how many terms will the product contain? How many terms? My question is
M plus n.
Term
m plus n or m plus n plus 1?
M plus N only, no, sir.
How many terms? P
Terms
of
means
x.
it will be plus 1, sir. Plus 1. Because it
How
will
many?
And
start from
including one
constant, no,
constant
sir.
also, so plus
Yeah,
one,
yeah.
sir.
Hmm.
M plus
Zero
n
Hmm.
plus
one.
one.
It start with
So
0. Yes.
0, 1, 2, and so on till m plus n. So there will be m plus n plus 1 terms. Okay. Terms means it will also have 0th power term also, constant term also
Okay, sir.
till the highest power.
Oh,
Okay.
okay,
So
sir.
that is how it
Thank you,
is. The
sir.
product will be
Thank
like
you, sir.
this. Yeah. Yeah. And what else? So what is the fourth question says?
Sir, I have a doubt in multiplicity, sir. How to find that multiplicity?
I will go to multiplicity now.
Okay, sir.
So this fourth question is also simple. Like we have given you p of x, q of x. You just have to product these two polynomials. You will get r of x. Then we have asked few questions like what is the degree of whether the degree of r of x is 13. The coefficient of x to the power 13 term is minus 16, like this. So just check whether which of the following are true and take them. I don't think this is difficult. And what about the next one? Division.
This one is also easy.
See, this is also okay. This is also okay, right? When a polynomial is divided by another polynomial. So use the division algorithm.
Third number, third
Hmm.
number.
Hmm. So which of the following is are correct? with respect to the division of a polynomial if the dividend and the divisor are given to be this, and they are not a constant polynomials is given to us. So firstly, tell me what is divisor, dividend, quotient, remainder.
Dividend is equals to divisor into quotient plus remainder.
Okay. So let me draw the okay. There is A, there is B, there is C, and there is D. Let's say. So everyone understood this, right? So this is the
B is a dividend.
division method.
Yes, sir.
Hmm.
B is dividend, A is divisor, C is quotient, D is remainder.
Correct.
Yes.
So B is dividend. Dividend, right? Dividend. So A is divisor, C is quotient, and D is remainder. Correct. So dividend is the numerator polynomial. Divisor is the denominator polynomial or with which we are dividing. C is once you divide, what is the quotient? Quotient means it's just like how many times I can multiply this divisor to get very closer to dividend. And the remainder is what else is remain? Something like if 7 is divided by 3, so 7 is dividend, 3 is divisor. So once I try to divide 7 by 3, so I can go till 3 times 2. So 2 will be quotient. And so this is how it will be 3, 2, 6, and 1. So I cannot divide this one again. So this one will be the remainder. So just like dividing numbers, we can also divide polynomials here. Okay. So here we have given you two polynomials, p of x and q of x. So p of x is given to be summation k is equals to 0 to n ak x to the power k, and q of x is given to be summation j bj x to the power j. So something like this. So we have given four options, right? So the first option is the division is possible when n is greater than or equals to m. Okay. So this is dividend. Given this is dividend, and this is divisor. So now we wanted p of x when if it is divided by q of x. So is this division possible for every case, or is there any condition between n and m? So the highest power.
Yes, sir. M when M
Dividend
n
should be
is
more,
bigger
no?
than m.
So this p of x is a naught, a1x, a2x square, and so on, an x to the power n, and it is divided by b naught, b1x plus b2x square, and so on, bm x to the power n. So so my question is, or the question is about whether this division is possible for every case, like for all n and m, or is there any restriction between n and m? So think like this. So what happens when n is greater than m? What happens when n is equals to m? What happens when n is less than m? So there are three possible cases. So we'll come to n greater than m case later. Okay, let's see n greater than m first. So what happens when n is greater than or greater than m? So whether the division possible? So something like numerator is having um, more power than the denominator. Something cases like, so for example, cases like x to the power 4, you are having in numerator, and in denominator you are having only x cube. So the division is possible, right?
Yes,
Yes,
sir.
and x is the
Mm,
quotient.
x will be the quotient and remainder will be 0. So if n is greater than m, so that means if numerator has highest degree, more degree than the denominator, so division is possible. What happens when n is equals to m?
Then
Both
answer
are
it will
will
be
be
there, but
cancelled.
only constant. That means x it will be cancelled completely.
Hmm. Hmm.
Like
So
let's say
n is equals to m
4x,
also.
Possible, sir.
Let's say 4.
when the power will be equal, like one example I'm giving, 4x to the power 4 divided by x to the power 4, then that
Hmm.
variable x will be completely deleted, only 4, which is a constant, will be left behind.
So 4 is the quotient here, and we are not going to get any remainder. And yeah, we can see that pretty much division may be possible. It is possible, right? Here also division is possible. What happens when n is less than m? Something cases like this: x cube divided by some x power 5, 2x cube divided by x power 5. So denominator is having more power than the numerator.
Then it will become minus, no, sir.
Then
We
in
have
that
seen
case, if denominator is having more power, then my numerator will be left behind as remainder only.
Remainder only. So we are not going to do any division, right?
Yes, sir.
Correct. So we, for that cases we say not possible.
not possible.
So you are not going to divide anything. So the numerator will remain as it as remainder, and there is no division. There is no such division possible. Okay, simply we say division not possible in this case. So our first option is something like the division is possible when n is greater than or equals to m. So this will be true. And now the second option is if p of x is a trinomial, then the quotient is always a trinomial. So when you see this words like always, must be, and so
Second one
if
is
there is something
wrong
like
statement.
guaranteed, huh?
Second one is wrong statement. Always it is not possible.
Yeah. So when you see these kind of fixed condition statements, always, must be, definitely, when you see these things, you try to get a contradiction. Try to get a contradiction.
Generally
Contradictory
also
example.
sometimes.
Hmm?
In some statement, generally is also used.
Uh-huh. Generally, okay, generally, will generally emphasize completely. I don't see this always, must be, definitely, and what else? Like the words which emphasizes, so all the possible cases, kind of. So all the possible cases. So if it is including all the possible cases, you try to bring a counter example. So even it fails for one example, the whole statement is false. So this particular statement says p of x is trinomial means the quotient will always be a trinomial. So try to take a trinomial example. So trinomial, if I take x cube, so let me take x plus 1 whole square. So simple example. So this will give me x square plus 2x plus 1, which is a trinomial. right? So this particular trinomial, when I divide it with any other polynomial, I will always get a trinomial, is the statement says. So if I take the other polynomial as something like x plus 1 whole square only, okay, I took p of x as x plus 1, q of x is also x plus 1 whole square. When I divide these two, I will get 1. So 1 is not a trinomial, right? 1 is actually a monomial. So one contradictory case, not only this example, you take any other contradictory example which fails the statement. So it should fail the given statement. So I hope you understood this.
Yes,
So
sir.
just bring the contradictory example. So when you see this terms like always, must be, definitely. So if you are unable to bring a contradiction, then the statement might be true. So then you need to prove that statement. Okay. I don't say always the statement which contains always, must be, definitely are always false. So there can be few statements, even if there are terms like always, must be, these kind of terms, the statement might be true. So that means that you will not get a contradictory example. So in that case, if you are unable to get a contradictory example, in that case, 95% chance that the statement might be true. Okay. So you have to prove that again. Once if you get a contradictory example, then don't need to worry. The quotient is always a polynomial. So is
False.
this true?
We got 1. So it is the monomial. Okay, okay.
Uh-huh. Is the
Yeah.
quotient always a polynomial?
Yes, no, sir. Even if we get constant also, it will be counted as monomial only, no, sir.
Okay. I think, yeah, if the division is possible, then you will get a quotient always polynomial. Correct, right? Am I wrong?
Yes, sir.
If the division is possible, then the quotient will always be a polynomial.
So only when we devise it, then only quotient
We
will
need.
arise, no, sir. So
Uh-huh.
always it will be polynomial.
Okay. In that case, we can treat it as correct.
True, yeah.
Now we have given m as some 6 and n is 4. So is the division possible? The denominator is having degree 6 and the numerator is having only degree 4. Will the
Yes.
division possible?
Yes.
Yes.
No, m is
No,
less than
it's
m.
four.
No, sir,
It's
the denominator is
No,
having higher
sir. It's
power.
n is equal to 4.
Hmm.
It's not possible.
It's not
are
possible.
equal to
Numerator
m.
is having less degree than the denominator.
Yeah.
So
It's
division is
just
not.
the extended version of first statement.
First statement. It's just the one case of first statement. So we have given a contradictory example to the first statement. Okay. So we are correct. So A and C are correct answers. Okay. So let's move to 4.6 then. So yeah, these all are dividend, divisor, quotient, remainder. We played around these things. Okay, try doing this. Question 4. So choose the correct option from the following. If f of x is given to be a 4-degree polynomial and g of x is given to be a quadratic polynomial and r of x is the remainder and q of x is the quotient. Now we asked you, we have said 4 statements. We have given you 4 statements. So division of f of x by g of x is not possible.
Statement.
So it is possible, right? So f of x has degree 4 and g of x has degree 2. So f of x by g of x is possible. So therefore option A is false. So what about option B? If f of x is divided by q1 of x, where q1 of x is given to be like 5x square plus 11x minus 28, then the quotient and remainder will be 2x square minus x plus 1 and minus 11x plus 10 respectively. So is this correct?
Yes, sir.
So if you know
That
how to perform the
was
division
nice.
algorithm, perform the division algorithm and do it. So I'll give you some 1 minute to try, 1 or 2 minutes to try.
So little bit
Okay.
zoom, no sir. Sign are not visible.
I will just zoom it. Okay, no doubts yet. I will just zoom that. Is it visible now? Is it okay now?
Yes, sir.
Yes sir. Yes sir.
Hmm. So just try. Even I will also try to do it after that 2 minutes. Okay, once if you are done, you can raise your hands or okay. Okay. Done? Done doing, yet to start. So where are you?
You have to complete.
About to complete. Okay, I asked to prove the second statement, whether the second statement is correct or not.
2 and for the answer.
Okay, 2 and 4 is the answer. Is it? Okay, let us solve this then.
Correct, sir. Correct.
Correct,
Okay,
sir.
statement 2 is correct, is it? Okay.
Yes, sir.
I will just
Yes
try to
sir.
perform the division algorithm. So those who are unable to solve it, you can watch it here. So f of x is given to be 10x to the power 4. Can someone read out? I just have to toggle between the terms. So 10x to the power 4
Plus
17x
17x cube
plus 17x cube
minus 62x square
minus 62x square.
plus 28x
Hmm.
minus 18
And what is the divisor given to us?
5x square
5x square
plus 11x
plus 11x
minus 28.
minus 20. Okay. So this is how the division algorithm will be. So I have to cancel out this 10x to the power 4. I have to bring this 10x to the power 4. So with what term should I have to multiply this 5x square so that I will get
2x
10 to
square.
10x to the power 4. So I have
2x
to
2x
square
multiply
square.
2x square. So 2x square, when I multiply it with 5x square, I will get 10x to the power 4. So now this 2x square, I have to multiply it to other terms also. So this 2x square will be multiplied, excuse me, multiplied with 11x. So that will become 22x cube. And this 2x square multiplied with minus 28 will get minus 56x square. We have to subtract. So this will cancel out. This we will get minus 5x cube. So 17 minus 22x cube minus 5x cube minus 62 plus 56 we will get minus 6x square. And I will just bring one more term 28x here. So now again the repeat the process. With what term I have to multiply 5x square so that I will get minus 5x cube
Minus x.
minus x. So if I multiply minus x to 5x square, I will get minus 5x cube. And similarly, this minus x, I have to multiply it with 11x and as well as minus 20. So if I do so, I will get minus 11x square plus 28x. Okay. Am I going wrong somewhere?
How it will become 11x square?
No, sir, right.
Minus x plus 11x, right?
Yes, sir.
Minus x
No, sir,
into
minus 11x.
Minus x into 11x. So it will be minus 11x square. So similarly, what we did in the above step, the same we are doing here also. So I will subtract this. So this will get cancelled. I will have 5x square and this will be 0 plus 0x and I will bring this 18 term to the down. Now, with what term I should multiply so that I will get 5x square. So 5x
Plus 1.
square plus 1. So I have to just multiply it with 1. So I need 5x square only. So plus 1. So 5x square. So plus 1 multiplied with 11x, it will be 11x. Plus 1 multiplied with minus 28, it will be minus 20. So once if I subtract, the sign will get changed. This will get cancelled and minus 11x plus 10. So once if I get the terms which are having less degree than the divisor, I will stop. Or with what term I should multiply 5x square? With what polynomial terms I should multiply 5x
This is
square
only the
so that I will get minus 11x? No, right?
this is only the remainder.
This will be remainder. So this is remainder and this is the quotient. Okay. So that is the option given. So the quotient will be 2x square minus x plus 1 and the remainder will be minus 11x plus 10. So this is correct. Next is q of x is 5x square plus 11x plus 28. Now g of x is 2x square minus x plus 1. Okay, once you see this, you can identify few things. So when I divide f of x by 5x square plus 11x minus 28, I am going to get quotient as 2x square minus x plus 1. Similarly, when I divide f of x by 2x square minus x plus 1, I will get quotient as 5x square plus 11x plus 20 minus 28. Is that correct?
Yes, sir.
So this is divisor. So you see, what I am saying is, I can write dividend
Is equals to
as,
divisor into quotient plus remainder.
yeah, divisor into quotient plus remainder. So you see, I can change this divisor and quotient. So if I make quotient as my divisor now, then my divisor will become the quotient. So this quotient, if I take it as a new divisor,
Multiplication is commutative in nature.
is commutative in nature. So if I take this quotient as divisor 1, then this divisor will become my quotient 1. Okay. And the remainder will be same. Remainder will be same. So here also in option 2, we have divided this f of x by this polynomial f5x square plus 11x minus 28. We got quotient as 2x square minus x plus 1. So which is g of x, nothing but. Now if I divide f of x by g of x, I will get my quotient as q1 of x. So therefore I have to choose for that option. So 5x square plus 11x minus 28, and the remainder will be same as it is, minus 11x plus 10. And you see f of x can be written as g of x times q1 of x or q of x plus r of x. So option D will be correct. Right? Let me
Yes,
check
sir.
the answer. Yes, we are correct.
Please explain multiplicity.
Okay, let's go to multiplicities and graphs now. Okay.
Sir, some squared error also.
We will end with some square error. Okay.
Thanks.
So for a particular polynomial, if I have to plot the graph of that polynomial, we have to look out for few observations or few things. So first and foremost thing is where the graph cuts x-axis, which are zeros of the polynomial. Okay. So what is zeros of a polynomial? Firstly, we have to understand this.
The roots of the polynomial are the zeros, right?
Roots of a polynomial equation are the zeros of our polynomial.
Okay. Okay.
So if I have a polynomial p of x to be equal to, I will just take an example and explain. I don't want to keep it as variables. So let us take something like 3 times x minus 2 x plus 1 whole square times x plus 5. Okay. So something like this. So this is a polynomial with degree
4.
4.
Yes. 1 plus
Yeah,
2
correct.
plus 1, 4.
Correct. So the degree will be 4. If you expand, so if you are confused how to find the degree from here with multiplicities and zeros, so just expand this polynomial, you will get the highest power to be equal to x to the power 4. Now, what are zeros of this polynomial means? Where the function cuts the x-axis. That means when it is cutting the x-axis, my y coordinate is 0. My p of x is 0. So the zeros of p of x are the solutions of the equation p of x is equal to 0. So whatever the solutions you get, whatever the roots you get or the solutions you get for the equation p of x is equal to 0, they are the zeros of p of x. So visually if I have to say, so once if I draw the curve, I definitely know that when I substitute x is equal to 0, when I substitute x is equal to 2, so 2 minus 2, this particular term will become 0 and the whole product will become 0. So x is equal to 2 is a solution of this equation. So x is equal to 2 will be a 0 of p of x. So the graph passes through this point. Okay. And there will be minus 1 also. If I take x is equal to minus 1, this particular second term will become 0 and the whole product will become 0. So let's say this is x is equal to minus 1. Similarly, there will be another solution also. When x is minus 5, this last term will become 0 and the whole product will become 0. Okay, so there will be 3 solutions for this equation. P of x is equals to 0. Therefore, there will be 3 zeros of this polynomial. And also, if I draw the curve, so I'll explain you. If you have attended the yesterday's session, maybe Vicky has explained how to draw the curve. This is how it will be. So you can see this particular curve of this P of x cuts x-axis at 3 points. So they are called as the zeros of the polynomial. Okay. So this is about zeros. And one thing you have to make sure is, before you draw the curve, you should definitely know what are the zeros of the polynomial. And the second thing you should know is multiplicities of the zeros. So what does this multiplicity mean is how many times that particular root is repeated. So in our example itself, so P of x 3 times x minus 2 x plus 1 whole square x plus 5. So if I find the roots of this polynomial, I will get something like 3 times x minus 2 x plus 1 whole square x plus 5 is equals to 0. So I am finding the roots. Once I find the roots, I let x is equals to 2 minus 1 5. So these are the roots I am going to get. But you see, this particular 2 is coming or occurring only once.
So there it is x plus 5.
Right, minus 5. Okay, x is equals to 2. The root 2 is occurring only once. So we say multiplicity of this root 2 is 1. So 1 is the multiplicity, because this particular root 2, not root 2, it is x is equals to 2 is the root. So this 2 is occurring only once. So the multiplicity will be 1 of this 0. So 2 is the zeros of this polynomial. So we call as 2 is the root of this polynomial with multiplicity 1. So we call it like this. So 2 is a root of
Sir, if the power of x plus 1 was 3, then it will be like minus 5, minus 5, minus 5. Minus 5 will repeat 3 times.
Okay, let's take 3 then. So minus 5, minus 5, minus 5. Okay. So 2
So
is
the
a root of
multiplicity then be 3.
3, correct. So 2 is a root of P of x is equals to 0. Sorry. Multiplicity 1. And if I see minus 1 now, so look at minus 1. Minus 1 is repeated twice. So minus 1 is being repeated twice, and you can observe it from here also. So x plus 1 whole square. So whatever the power is there, that will be the multiplicity. So it is x plus 1 whole square. I can write it as x plus 1 times x plus 1. So for x plus 1, you will get 1 root minus 1, and the other x plus 1 you are going to get again minus 1. So your minus 1 will be repeated twice. So I say minus 1 is a root of P of x with multiplicity 2, because minus 1 is repeated twice. So I am getting minus 1 2 times. So multiplicity will give me how many times this root being repeated, that particular root being repeated.
And sir, this we can visualize with the wavy curve method also. Like both the side nature will be same, because
Both
it
the
is even like wavy curve method is there, plus minus we put. So like here, the per degree is even number. So there both side nature will be same. It will be minus minus or plus plus. By putting that we can check, and graph will be also, curve will be also on the same side.
Hmm. Hmm. In similar terms, we can say bouncing, bounce back or
Yes, sir,
cuts.
exactly.
Yeah. So you can call it as 2 is a root of p of x is equals to 0, or you can call it as 2 is a 0 of zeros of p of x, 0 of p of x with multiplicity 1. Minus 1 is a 0, zeros, sorry, zeros of p of x with multiplicity so 2. Similarly, if I see minus 5, when I go for minus 5, x is equals to minus 5 is a 0 of this polynomial, but minus 5 is repeating thrice, 3 times. So minus 5, minus 5, minus 5. That you can see with the power of x plus 5. So x plus 5 term has power 3. So I say minus 5 p of x with multiplicity 3. So how many times this particular zeros or the roots is being repeated is called the multiplicity. By looking at the multiplicities also you can draw the curve. So for drawing the curve, this multiplicity also plays an important factor, is an important factor. So the next thing is end behavior. You should definitely know how the end behavior will be.
Sir, that cube minus 5,
Hmm.
how that curve will look like, sir? Supposing two roots are minus 1 means, why will
Hmm.
be 0 and that curve will not intercept with the y-axis? It will
Hmm.
bounce from the x-axis. That is the meaning, no, sir?
Hmm. Hmm.
And supposing minus 5 thrice it is coming means, how the curve will look like?
Okay, that curve will look like this. So there will be 3 cases possible. Okay,
Yes.
so at the places of roots, suppose this is a root. So these are the 3 cases. If the multiplicity is equals to 1, okay, this is the first case. When the multiplicity of that particular 0, let's say this is the root or the 0, if the multiplicity of that 0 is 1, then the curve simply passes through it, cuts and passes through it simply.
Okay,
There
sir.
will not be any shape change also.
Okay.
So something like this will go very smooth, or it can go from down to top also, cut like this also. Okay,
Okay.
but very smooth. There will not be any change there.
Okay.
Okay, or in terms of tangents, the slope at that particular point will not be 0.
Okay, sir.
Okay, at this, if you compute the slope at that particular point, at that particular uh, root, it will not be 0. Okay, the next case is when the multiplicity is even. Okay, even if I say 2k where k belongs to natural numbers, when the multiplicity is even, it will bounce back. So bounce back means it will come to the root and it will not cut the x-axis, it will again go back.
Both the side
Either it will
values
be
will
a
be of same nature.
same nature.
Got
So if it is positive, it will continue to keep positive. If it is negative, the left side nature is negative, the right side will also be negative. So
The bounce
usually
back,
if you want
but
to, yeah, hmm?
bounce back, but there will be no sharp edge.
There will not be a sharp edge, correct. So it will simply bounce back. Okay, so something like these cases. So this case or this case when it is even.
Okay, sir.
And the last case is K is from, okay, K not equals to 0 and K belongs to natural numbers. So K not equals to 0, because if K is equals to 0, then it falls into the first case, multiplicity being 1. So if it is not equals to 0, then the multiplicities are either 3, 5, 7 like this. So odd numbers. So then the curves will be like this. So it will come like this and it will change. So the slope, if you compute the slope at this particular point, the slope will be 0. Or it will be a sudden change in the slope, sudden change in the nature of slope. Will there be a change? No, there will not be a change. The slope nature will be same. So if the slope is negative in the above, so the slope will be negative. The same negativeness continues on the right side also. Okay, if you don't want to go in that deep, okay, it's fine. But there will be a slight change in the curve shape. So something like this. It will follow something like x cube, if you know minus x cube curve, or x cube, you know x cube, right?
Okay.
So it will
Yes,
be like
got
this.
it.
Concavity of the graph will change. Concavity of the graph will change.
Okay, if you can understand that, the convex nature or this particular shape, so from here it will be like this. So it will take a turn kind of thing. Okay,
Okay.
when you, so treat it like a road. So there will be some uneven turn. Okay.
Okay.
So this is about multiplicity being odd and also greater than or equals to 3. So it will follow the shape. So as this particular multiplicity increases like to 11 or 12, the curve will more and more come closer to x-axis, something like this. It will be like this.
Okay.
So these are the three possible variations of the graph near the zeros.
Okay.
Depending upon the multiplicities and zeros of the polynomial, you can draw the curves. And also one more important thing is end behaviors.
End behavior. Okay, sir.
There are 4 end behaviors, I guess. 4 possible end behaviors. Both are being upward, both are being downward. One being the left side being upward and the right side being downward, and left side being downward and the right side being upward. So like this. Both are being upward, both are being downward, or left side will be upward and the right side will be downward, or the left side will be downward and the right side will be up. So these are the 4 possible end behaviors. Do I have to go in deep about this? I think it was explained in
End
yesterday's
behavior
class.
will go deep, sir. End behavior.
So end behaviors means, so once you arrange your roots, first of all you need to find the zeros of your polynomial and plot it on xy plane. So arrange it on x-axis. So once, let's say these are your roots. So consider the leftmost root and the rightmost root. So that means this root and this root. So end behavior means the left side of leftmost root, which is this, and the right side of highest root, or the right side root. So this. So end behavior means where, how will my graph or how will my function behave when x tends to minus infinite or x tends to plus infinite. So that is what end behavior means. So this end behavior can be of different types. There can be 4 different types depending upon depending upon the degree of the polynomial and the leading coefficient. So if I say leading coefficient to be a and the degree to be n. So first case is, so case 1 is when your leading coefficient is greater than 0 and when n is even. Okay, this is first case. So leading coefficient being greater than 0 . So you understand what do you mean by leading, what do I mean by leading coefficient, right? So highest degree term ka coefficient. So when it is this case, so the end behaviors will be both will be on the positive side and both will be yeah, both will go to plus infinite when x tends to infinite. For example, cases are like this. So n being even, x plus 1 whole square. So you see quadratic equation, quadratic functions which have leading coefficient greater than 0. So they will be like this, right? Both the end behaviors are upside. When n is even, so n is even means n is the degree. So if n is even, so inside you don't need to worry. Inside is related to zeros and multiplicities. By looking at the zeros and multiplicities, we can draw the graph. But the end behaviors, you can draw it using only the leading coefficient and degree of the polynomial. So if the degree is even and your leading coefficient is greater than 0, you will have end behavior like this. And case 2 is, if a is greater than 0, your leading coefficient is greater than 0, but n is odd here. So this will be case 2. So for these cases, so the left side will be downward, or it will, when x tends to minus infinite, my polynomial value will go to minus infinite. When x goes to plus infinite, my value goes to plus infinite. So it will be, one will be downside, so the left side will be downside, the right side will be upward. So for example, you can check x plus 1 whole cube or x cube simply. So x cube curve also will be like this. So the end behavior on the left side will go downwards and the right side will go upwards. Similarly, you can take few examples by yourself, no need to be provided. Okay, you randomly take one example and try to draw the graph of that. So this is case 2. So these are the only 2 cases for leading coefficient being greater than 0, and other
Sir,
2 cases are
I have doubt in the second case. How did you decide that first and third quadrant? Why not it start from the second and fourth, ending with fourth quadrant?
ending with fourth quadrant means when x is something like this, right? You are talking
Yes,
like this.
it will start from the second and
Uh,
end
uh,
with the fourth, exactly opposite. So
uh,
how do you decide that you started from first and ending with third, not
how do I
with from
decide it is
yeah
as the leading coefficient is greater than 0. Okay, so the leading
yeah
coefficient which changes the value of the function, it is positive. Okay, treat it like that.
yes
So something like 3x square minus 2x, okay, 3x cube minus 2x plus 1. Okay, something like that. So as I increase the value of x, okay,
hmm
So if I increase the value of x, this 3x cube term will become larger and larger because this is the cubic term,
Okay.
right? And
Yes.
this is positive. Okay.
Yes.
As x tends to infinite, this will go to infinite. Correct?
Okay. Yes.
And these
Yes.
are just the linear terms, and this will not vary much, even though they are minus, even though they are negative values. This
Mm-hmm.
is very, very huge compared to these values as x increases.
Okay.
Correct? So when
Yes.
x is 10 or 100, when x is 100, this is something like 3000. The value is 3000, and this is just 200. Correct?
Correct. Correct.
Uh, so the power will lie in the hands of the leading coefficient and the leading term. So that is why we call it as the leading. So it will lead the value, function value, on the polynomial value. Okay.
Okay, sir. Okay.
So it
Thank
will
you.
only depend on that particular leading term. So as x tends to infinite, this will go to infinite. When if my a is greater than 0, this will go to infinite. So as x tends to infinite, it should go to infinite on the positive direction, not on the negative direction. This will go to the negative direction. It will go to minus infinite.
Yeah.
Correct?
Correct.
So
Yes.
this
Correct.
is not one. But whatever you said is the possibility for another case. We will see that also.
Okay. Thank you, sir.
Yeah. So in the case 3, we will see when a is less than 0 and n is being even. Okay. The leading coefficient is negative now. Okay. So what happens? So what happens? When an a is positive, both are on the same directions when n is even. Here also both will be on the same direction, but on the negative side. So something like this. Sorry. Something like this. For example, minus x square. So here the leading coefficient is minus 1, which is negative, and n is even here. So minus x square graph, if you see, it will be like this. So both are going to minus infinite. Both are below x axis. And similarly, you can see minus x or 4 plus 1 or something like this. So even this is also will be like this. Okay. So even here also you can see both the end behaviors. So there are only two routes possible, and both will go like this. So something like this. So both will go to the negative direction. So it will follow this nature. So when a is less than 0 and n is being even, and the final case is so case 4, we will see what happens when coefficient is less than 0 and n is being odd. So in this particular case, so whatever he said, the left side will go to come from plus infinite and the right side will go to minus infinite. For example, minus x cube. So minus x cube graph will be like this. So the leading coefficient is negative and n is odd. So you see, when x goes to infinite, this x cube will go to plus infinite. But when I multiply it with negative value, it will go to minus infinite. So larger and larger on the negative side. So as x tends to infinite, it will go to the negatives. And as x tends to minus infinite, usually x cube. So when x is tending to negative value, when x is taking smaller and smaller values like minus 100, minus 1000. So this x cube will be smaller and smaller. But once I multiply it with negative value, it will become positive and it become larger and larger. So it will go to infinite. When x is tending to minus infinite, it will go to plus infinite. When n is odd. When n is even, so when n is even, what happens? Even though x goes to minus infinite, x square will be positive. X square being positive, minus of positive will be negative. Again, it will be negative. It will go to negative. So that is why both will be downside. In this case, the left side will be on the upside and the right side will be on the downside. So this is about, these are the only 4 possible end behaviors, graphs of end behaviors. So both being upward, one being downward and the other being upward, both being downward, and one being upward and another being downward. Okay. So this is about end behavior. Now you can draw the graph. So I will draw the graph now. So let us try to draw the graph of this. Okay. So just tell me what will be the leading coefficient, whether it is positive or negative. Firstly, plot the roots. Okay. So what are the roots possible? -5, -1, 2. Now the leftmost root is -5 and the rightmost root is 2. So what will be the leading coefficient? Is it positive or negative?
Positive 3.
Positive.
Positive. Leading coefficient is this. And there are no negative signs for x inside each and every term. So a is 3 and which is positive. And compute the degree. How do we compute the degree? Using the roots, zeros and multiplicities. So if you have like this, just add the powers, just add the multiplicities of the roots. So the multiplicity of the 2 is 1, multiplicity of -1 is 2, multiplicity of -5 is 3. So the degree of this polynomial will be 1 plus 2 plus 3, which is 6. So 6 is an even number. So even degree with a being greater than 0. How will the end behavior look like?
Upward.
A being greater than 0 and it is even degree. So both the end behaviors will be upward. So draw that first. So it will be like this. This will be like this. Okay. Now once you draw this, you can start from 2 or -5, whichever way you start. So look at -5. So once you look at -5, you see the multiplicity of -5. So multiplicity of -5 is 3.
3.
So as we have discussed, if the multiplicity of a root is odd and being greater than 1, then it will there will be a slightly shape change and cuts the x-axis. So it will be like this, it will come like this, and it has to take turn again. So because it has to come to -1, so it will take turn and comes to -1. Once it reaches -1, you just see the multiplicity of -1. So the multiplicity of -1 is 2, which is even. So now it falls to the second case. So this case, multiplicity being even of the root. So if the multiplicity is even, it will bounce back. Okay. Why did I leave this page? Okay. From -1, it will bounce back and comes and reaches to 2. So once it reaches to 2, you see multiplicity of 2 is 1. So it is odd. It is the first case now. So once if it is the first case, it will just go simply. It will not change anything. So it should match this end behavior, this side end behavior. If you start from 2, if you are drawing the curve, it should exactly match to -5. So it shouldn't be like this. So you are drawing some roots are there. You have drawn something like this, and the multiplicity of this is 2, and you have drawn end behavior like this. So this will be, this is wrong. You have done something wrong here. So you have to go back and check what you have done wrong. Okay. So what I meant is multiplicity. City of this root is 2, and you are getting like this case. So end behavior you have drawn like this, and you have started drawing the curve, and you have reached to this situation. So you have to bounce back. If you bounce back, you will be going the other way, not on the direction of the end behavior. So that means there is something wrong in your drawing. So you should go back and check. So here our graph matches exactly. So this is a rough graph. This you can say P of x. Okay, this is about graphing, and this is the difficult part in week 4. And as someone requested about SSC, is he there?
Yes, sir. Yes.
Sum squared error. Okay, so the name itself gives us few hints: sum, squared, and error. So when do we find error? So usually in our real life also, we are very much interested to predict future, right? So if a match is going between India and maybe Pakistan, so we are very enthusiastic that India will win today, or we will try to guess few things, right? Or today Rohit will hit 50. So there will be predictions, right, in day-to-day life. So everything we will try to predict and analyze the situations. So during these predictions, not every time you will be correct. Yes or no?
So,
Correct, right? So if I predict like I'm going to end this session within 15 minutes. I don't know whether it will end or not, but this is my prediction.
It will.
Ah, it should. Okay. So, or maybe like in the finals of road safety match is going on, India will win. This is my prediction. And when do I get to know whether my prediction is correct or false? So when do you get to know
End of
your
the match.
prediction? Huh?
At the end of the match.
At the end of the match, or once the event has happened. So once whatever you are predicting, it is happened, then it will become actual. So what is actual and what is prediction? Then there will be a term called error, which is associated between prediction and actual. So actually something has happened. You have predicted something. What is the error in your prediction? So how will I compute this error? So there are different ways. In our mathematical scenarios, we treat error as the difference between those two. Okay. So you are rolling a die. Just say you are rolling a die. So you are predicted that the number will appear to be 6. You have rolled the die, but the number to be equal to 4. The die number is 4. So the error in your prediction is 6 minus 4, which is 2. Okay. Uh, maybe in maths 1 course, we treat error as difference. Not always error is difference. I'm I'm making sure of it that error is not always the difference. Okay. In these scenarios which we are going to deal, we treat error as the difference in prediction and the actual. Actual minus prediction is the error. So once if you are convinced with that, this SSC is nothing but some squared error. So what is the error? Being squared, and if you add that some summation, sum of the squared errors is what SSC is. So for these things, we will give you an predicted equation. Okay. So something like okay, you are in front of a machine. So you know what that machine is, and we asked you to input few numbers into the machine. Okay, you have to input numbers like 1, 2, 3, 10, 20, like this. So you have to input numbers into this machine. and this number this machine will do something inside it, and it will give you some other numbers. So output is also a number. So once you input some numbers into this particular machine or computer, it shows you few numbers. So like this, you have input few numbers. Let's say you have input 1. So you have input 1, you have input 3, 4, and 7. Okay. Once you input 1, so these are your inputs. So once you input 1, your computer is giving as output 3. Once you input 3, it is giving output 4. Once you input 4, it is giving output 6. Once you input 7, it is giving output 9. So by looking at these inputs and outputs, we will try to predict. What we will do, we will try to predict what. So without even inputting some 9 or 10, you will try to predict if 1 is inputted, I am getting 3. If 3 is given, it is giving 4. If 4 is given, it is giving 6. If 7 is given, it is giving me 9. So if I input something like 13, I can guess that my output will be greater than 13, because whatever the input I gave, my output is being greater than the input, somewhat greater than the input every time. All these 4 cases, it is being greater. So my prediction will be, if I input 13 also, I will get a output which is greater than 13.
15.
Right. See, this is the prediction. So without even knowing what the computer is analyzing, you have predicted something, right? You have predicted, like, when I input 13, it should give me 15. So this is your prediction, but the actual can be anything. Okay. So like this, what we have, how did you guess that equal to 15?
All the input except the second one, while x plus 2.
So what we have done is, out of the 4 possible cases, in the 3 cases, if you observe, whatever input I gave, my output is coming to be plus 2. So plus 2 of the output, plus 2 of the input. So this will be my prediction. So I will simply predict that whatever input you give, my output will give me plus 2 of it. So this is the prediction. Simply in terms of x and y, let's say this is x and this is y. Input as x and output as y. And this is my prediction. What is my prediction? My y will be x plus 2. So this is prediction. And these are the actual values I have seen. Okay, these are the actual values and this is the predicted prediction. So now I have to find my error. So error is basically prediction minus actual or actual minus prediction. So I am interested to find how accurate I am. So accuracy comes from minimizing the errors. So I am very much interested to find how accurately I can predict. What is my accuracy? So in order to find that accuracy, I need to know my errorness. So my error is nothing but actual minus predict. Okay. In all the 4 cases, I will find my actual and predicted. So my actual values are 3, 4, 6, 9. Output values are 3, 4, 6, 9. But my prediction, how will my prediction be? Prediction outputs be? So my predicted outputs, let me write it down here. So actual outputs are, so these are the inputs, 1, 3, 4, 7. Actual outputs are given to be 3, 4, 6, 9. My predicted outputs So it is like input plus 2. Predicted outputs are just input plus 2. So 1 plus 2, 3. 3 plus 2, 5. 4 plus 2, 6. 7 plus 2, 9. So these are the predicted outputs. So my error in each case will be actual minus predicted. So actual it is 2, 3. Predicted is also 3. So the error will be 3 minus 3 in this case. Are you guys getting this, or am I going too speed, or?
Yes, sir. Getting, sir. One is the answer.
So here in this particular 3 case, I predicted that when I input 3, my prediction is that it should be giving my output as 3 plus 2, but instead it gave you output 4. So there is an error. So that error is 4 minus 5. And here also the actual is 6. Our prediction is also 6. So 6 minus 6, there is no error. Good prediction. Actual minus, so in this case also, when I input 7 also, my actual output is 9. My predicted output is also 9. So 9 minus 9. So this is the error. Error is 0, minus 1, 0, 0. Now what I have to do? I have to square the error. So once I square the error, it is 0 square, minus 1 square, 0 square, and 0 square. And what finally I have to do? I have to sum the squared errors. So 0 square plus minus 1 square plus 0 square plus 0 square. So you are going to get 1. So 1 is the sum squared error out of those 4 predicted, out of those 4 values. So out of these 4 values, you have gone wrong, or we have guessed wrong only in one case, and in that case also the error is very less to like 1. So only 1, it is difference of 1 we have. So the sum squared error, we got it as 1. So that means our prediction is a very good prediction. So we can, so whatever the equation we have come up with is, so this is a very good prediction based on this given set of actual values, based on these values only. I hope I have given some clarity about what is sum squared error. Okay. So not every time our predictions will be correct. So you can predict something, and the same scenario, your friend might predict something else. So you might predict something like y is equals to x square plus 3 is the best prediction, and your friend can come up with very complicated expression, maybe like log of x square plus 3 plus minus 1 to the base x minus 1 plus some constant 2x, something like this. So he might have some more knowledge in logarithmic functions, and he has come up with some best possible prediction, but you have predicted like this. So in order to test whether your prediction is better or not, what you have to do is you will use this method. So this particular sum squared error, so whose prediction is more accurate or whose prediction has less error, that will be considered as the best prediction, right? Even in our normal life also, if we go very closer to the actual predictions, we will be very happy, right? Somewhat happy. Yeah, we will be like, yes, I already told this, something like this, right? So I have predicted very nearer, so it
Whenever
will give us
the
some. Hmm?
it is
Whenever I'm unable to hear you.
whenever result
See, I can only hear whenever.
actual
Sorry, is my connection
good
bad?
predictions are
No, sir. Her voice is only disturbing.
Yeah. See, maybe your internet connectivity you have to check once. So okay, this is about SSC. So now this SSC is nothing but you are trying to find the error, some squared error. What error? It is actually the error between the actual given data and your predicted equation or predicted data. So you have to subtract those two, square them, and add all them. So this is one method. See, this is sum squared error is only one. What we say? One way of predicting the best fit lines. There is also modulus error. There are few errors. Once you come to machine learning course, you will see there are different kind. Absolute error also is one error which we look into. But as of now, we only look at sum squared error. Okay. Okay then.
Okay. So can you explain mock
Today
test question number
mock test.
question number 10?
Okay. Okay, I will explain.
Second, sir.
But
Sir, 1 second, sir. Thank you for the session, sir. I am leaving the meeting, sir.
yeah, sure. So I'm done with today. We have discussed few things. I hope tomorrow also there is session. You can come to that session, and if you have further doubts, you can clarify in that session. Okay. Thanks
Thank you
for
very much.
joining and have
Hours
a
are
great
also
day.
there.
Thank you, sir. Bye.
The office hours
Thank
are
you,
also
sir.
there.
Thank you,
Thank
sir.
you for the session, sir.
Okay.
Thank you, sir.
Yeah, office hours also there. Okay. Okay. Thanks a lot, guys. And yeah, those who have few doubts, just ask me. I can be here for some 3 to 4 minutes.
Hello.
Okay, the mock
Yeah.
test question.
Hello, sir. Abhinav this side. It is not regarding the session, but the score that I have, I have got in week 3 graded assignment. So comparatively comparatively from week 2 graded assignment, in week 3 assignment, I scored a comparatively very low score. But in particular to question number 8, in which I have marked 4. And the answer the computer is showing is 4.0, but I have been given 0 score. So
question number 8.
Yes, question number 8. So I don't know whether it is a computerized error or from your side you have discarded, not considered.
We discarded that.
You discarded that.
Okay. That question is about slopes at 2 different points, right? Is that?
Just a moment, sir. Just a moment.
So we have
slopes. Yes.
Slopes at 2 different points.
Yes.
So in 2 different cases, you are getting 2 different C values. So we have discarded that
if the
question.
Slope of parabola, so you have discarded it, right?
We have discarded. That is why it is 0. I hope.
Okay.
Okay. What is the mock test question doubt? You have someone?
I was not the person who raised that.
Yes.
I guess.
Yes. Question number 10 and 11. Like it is regarding, I think, SC only.
Oh, question number 10 and 11. Just a second. Let us solve that one also then. Just a second. Let me open that. Okay. Question number 10. Okay. So is this about minus 1.6 and plus 1.6? Something like that? No? Maitreya?
Yes, it is something like anthropological detectives measure the length of tight bones to estimate the.
Okay. Is your doubt related to something like why not minus 1.6? Or full answer?
Full answers.
Okay. So we have given, this is a contextual question, right? It has some context attached to it. So anthropological detectives measure the length of dried bones to estimate the living height. So what is the scenario here? So they take the dried bones and looking at the bones or testing on the bones, they will estimate or predict the height of the living being. Okay, so this is what they are going to do, their prediction is. And we have given something like height equations based on the bones they got. If they got the femur bone, so femur bone, by looking at the femur bone and testing the femur bone, they have predicted that. So this is their prediction. Height is actually equals to 1.9 times f plus 32. Okay, what does this mean is, if the femur bone height is something like 110 centimeters, then the height of the person is predicted to be 1.9 into, is it in meters? Inches. Okay, so let's say 10 inches. So they found 10-inch femur bone. So then their prediction is that if they found if the femur bone height is 10 inch, then the height of the living being will be equal to 1.9 into 10 plus 32 is their prediction. So this is what their prediction is about femur bone. Okay, like this they have few more predictions also by depending upon the bones. So not every time they will get femur bone, right? They might get something else like humerus bone or radial bone or tibia bone. So we don't need what that means, but they consider that there are 4 different types of bones, and depending upon each type, their prediction is different. So if it is femur, it is 1.9 f plus 32 for males, and there is differentiation between male and female also. So this is for male, and there is another equations for female also. So similarly, so if it is femur, their prediction is like this. If it is humerus, it is 2.9 h, so 2.9 h plus 27. If it is 3 radial, 3.2 r plus 33.8, 3.2 r plus 33.8, and if it is tibia, 2.3 t plus 30. Okay, these are their predictions. So just now we discussed prediction is different and the actual is different. Okay, so the question says a 14-inch humerus bone from a male subject has been found. So what did they give us? They have found 14-inch humerus bone, or you just simply take it as type 2 bone. Okay, they found the type 2 bone, and what else they know? What will be the error if the bone belongs to a 66-inch tall male subject? So it is also given that 14-inch humerus bone belongs to 66-inch height person.
Sir, your screen is not visible, sir.
Is my screen not visible?
Yes, sir.
Visible, right?
Yes.
For me only.
It's visible.
Visible.
Yeah, it's visible.
We'll quit and rejoin.
So this is the actual data given to us. So what is actual? This particular 14-inch bone, a humerus bone or type 2 bone, belongs to 66-inch height person. So this is the actual given to us. But what is our prediction? Our prediction is something like this, right? If I found the humerus bone, it is the height. The height I will predict as 2.9 times that humerus bone length plus 27. So my predicted height h is 2.9 into this height of this humerus bone, which is 14 plus 27. Okay, so now what this will be? 29 times 14, 2.9 times 14, What is this?
$40.6.
40.6.
6.
Total.
Plus 27. We are going to get 67.6. So 67.6 inch is our prediction height. So this is what we predicted. But what is the actual height of the person? It is 66. What will be the error in the prediction?
0.6.
So 67.6 minus 66. It should be considered modulus of error. You can consider it modulus. So it will be 1.6. So the error in prediction is 1.6. Okay. So this is how the error in prediction we can get. And what is the second question is about? Second part is about just a second. Na? 1 second. Okay, sorry for that. What was the second part? Second part is about a student calculates the living height of a person using the formula. Now he don't want to use separately. So if he found femur bone, or if he found humerus bone, or if he found radial bone, or whatever bone he found, he just wanted to combine everything and look at the height of the person. So he wanted to take all the bones into the consideration and 0.3 times. Let me share that screen and explain it there only. Okay, you try solving that. Let me share that screen. Okay, this is the question. So a student calculates the living height of a person using the formula. Now he don't want to compute HF, HH separately. So he wanted to combine all these four equations. And how he wanted to combine? He wanted to take 0.3% of, or 30% of HF, 20% of HH, HR, 20% of HR, and 30% of HT. Okay, so 30% is nothing but 0.3. So where HF, HH, HR, HT are heights calculated by FHRT respectively. Okay, so you just replace HF by 1.9 F plus 32. Similarly, HH by 2.9 H plus 27. HR by 3.2 R plus 33.8. So just replace everything with FRHT. And once you replace and compute the value, just simplify, you will get some simplified values. Okay,
Okay,
for
only
male and for
substitution
female.
simplification.
Hmm?
Only substitution simplification.
Substitute and simplify.
The last
Do
one,
it
the
for
12th.
do it for both. Do it for both male and female separately. You will get.
Okay.
And the last one, you see, choose the best representation of height of a female person versus the length of the bones FHRT. Okay. So what you have to do, you have to draw these lines. So these are straight lines, right? So consider this H as Y and FHRT as X. So Y is equals to 1.9x plus 28, Y is equals to 2.7x plus 28, Y is equals to 3.3x plus 32, Y is equals to 2.3x plus 29. There are four lines. So try to draw those four lines, or you can see the y-intercepts. Y-intercepts are 28, 28, 32, 29. So I should have three different y-intercepts. If you see here, in this particular option, Are these the options? Yeah. So in this particular option, all the y-intercepts of each and every line is same. So option A cannot be true. In the option B, you see 2 lines starts from one point and 2 lines starts from another point. So this is also false. Correct? So 2 lines should start from one point, which is 32, I guess. 32 or some, what is that? 28. So we have only 28, 32, 29. So 28, 28 should be repeated. 32 and 29 should be different. Okay, option B is also wrong. So now you see option C. So it can be 28 and this can be 29 and this can be 32. So this might be a possible option. Let's check for option D also. Option D, if you see, below one is 28, it has only one. 29 is repeating twice and 32 is repeating once. So which one will be the correct answer? Third one. So 28 repeating twice, 29 once, 32. Okay?
Okay, thank you.
Okay. Okay.
One question.
Hmm?
Sir, can be either can be negative?
In general, error is positive, but sometimes error can also be negative. Sometimes if we talk in regards of direction also, direction means lesser and greater also, negativity matters. Negative matters. Okay. So your point is like in that question, why not it is minus 1.6? Is that the question,
No,
or in
sir.
general you are just asking?
In general, sir.
In general, error can be negative. That is why in this sum squared error, we will square it. We will square the.
Okay.
In order to remove that negativeness, we will square it. Similarly, you can do absolute also. Just think about this. Why are we only present dealing with only squares? If we wanted to remove that negative or the negative values of error, why are we squaring it? Why not take the absolute value? Why not we take the modulus one? Even modulus gives us positive values only, right?
Yes.
Why why aren't we considering modulus or the absolute? Why are we considering square? Okay, just think about this. Okay, then let's end this session
Sir,
today.
I have a
And
question from graded assignment 3.
which question?
Sir, question number 2. If two lines are parallel, they never be intersecting. Right, sir? So, sir, in question number 2, one options line 1 and 3 are parallel. Then another option gives that line 1 and 3 intersecting at point X and Y. So how can it true, sir?
Line L1 is parallel to
3.
Options. You are asking about options, is it?
No, sir. Line 1 is parallel to 3. It is correct.
Line 1 is parallel to 3
Line
is
3.
correct.
Is this graded exam
Yeah,
problem?
with 3. Question
Yeah,
number 2.
even I got the wrong answer.
See, just
Sir,
check again. L1 and L3 will not be parallel. L1 and L2 will be parallel.
no, sir.
No, it's a question is
Option is
different.
correct,
I think
sir.
it has two
Means
parabolas.
line 1 is parallel to line 3. It is correct. But another option also correct mentioned that line 1 and 3 intersecting at some point.
So it's the second question in practice assignment, week 3.
Graded assignment, right?
Graded assignment.
Okay, I will just show you the question.
Yes, sir.
And the answer is also given, right?
Yes,
So is
sir.
it a parameterized question? No.
No, it's a
Not
parabola
parameterized.
and lines.
Parameterization
Yes.
means different values. No different values. This is the question, right? You are talking about.
Yeah, sir. Accepted answer, sir. Line 1.
L2 are parallel. Just check. That is what I am asking you. So whatever you got, see here, suppose a straight line L1 passes through the point A with slope equal to the slope of the parabola y is equals to minus x square minus 5x minus 4 at point A. Okay, and we also given that point A is not on the x-axis. So see this particular condition. So we have given point A is not on the x-axis. So I think you have taken point on the point A as which is on the x-axis. So you will get these two parabolas intersects at two different points. One point on x-axis and another point not on x-axis. And which is not intersecting on x-axis, that point you should be treating it as A, point A. Okay, the point which is on the x-axis, meeting intersecting point on the x-axis is point B. I guess you have gone wrong here. Just check again and try
Yes,
to
sir.
compute. This time you will get L1 and L2 are parallel.
Sir, sir, can you see question number 3? They gave the 0 point. Is question discarded, sir?
Question number 3, right?
Yeah.
Suppose f of x is equals to ax square plus bx plus c. Is this the question?
Yes, sir.
So where did you go wrong? We also did this in solve with us
Yes,
session,
sir.
right?
Yes, sir. Yes, sir.
Mm-hmm.
Sir, no, sir. Seen 0 points. Given the 0 points means this question is discarded, I think.
Oh, is it given 0 points?
Yes, sir. In that solve with a session, it's simple. Means if we separate split equation, it's very simple. But in this question,
In this question, what happened? See, we have given a, b, c as integers, right?
yes, sir.
So once we have given them as integers, and also the sum of the roots and the product of the roots are minus 7 by 4 and minus half. Can't we find? Okay. Okay, let me check with this. I think we can find. I don't know why they have given 0 points. Maybe if they have given 0 points, that means this question is also been discarded.
Yes, sir. Sir, in your screen, answer accepted 34, but in my 50.
Array, that is parameter. We have changed something 6a plus 2b plus 2c is the question for me, right? So might be your question is something like 5a plus 3b plus something else.
Yes, that's a
Yeah,
different value
4A
for
plus
me.
6B plus 4.
So
Yeah.
not everyone will get the same set
Yes,
of
sir.
questions. Okay, we will check about this. And
Okay, sir.
if it is 0, that means there might be an error. So don't worry about it. Okay then.
So graded assignment solution is not shared for week 3.
It will upload. It will upload today.
Yeah.
Okay, sir.
Okay.
Yeah.
Thank you, sir.
Okay.
Thank you, sir.
Thanks. Yeah. Thanks a lot, and we will meet you in the next session. Okay.
Yeah.
Around 2 o'clock, one session will be there, no, sir?
Afternoon 2 o'clock. I don't know about that. Is it office hours?
Yes, sir. Okay,
Yes,
sir.
Yes, sir.
Okay. Then it will be there. It will be there.
Okay, sir. Thank you, sir.
Okay. Thank you.
Thank
Thank you so much,
Your
and have a
throat
good day.
having civic cough and with great difficulty you teach us. With your throat, you are having cough, even then continuously you are
Okay.
talking, sir. Take care, sir. Thank you.
Okay. Thank you. Thank you so much. Bye.